Hello students, welcome back to my channel. In this video, we will do the algorithm for insertion sort and also implement insertion sort in Python programming language. Okay, so starting with the algorithm first, the insertion sort function that you write in any coding language will take the list that you have to sort as an argument and the length of the list. Okay, now inside the function, we are maintaining again two important variables I and j. I basically keeps track of number of sorted elements, and it also keeps track to which unsorted element we have to now put it at the correct position in the sorted part of the list. So I will be initialized to 1. So this is a big difference from the bubble sort and the insertion and the selection sort algorithm. There we initialized I to 0. But in insertion sort, in the very first pass, we assume that one element, which is the element present at index 0, is already sorted. So I is equal to 1. Now we will run a loop, either a while loop or a for loop, however you want to code. And this loop should keep track of the number of elements that have been sorted till now. So as long as n minus 1 elements, or rather n elements, have not been sorted, so we'll continue the iterations, we'll continue this loop, and then inside each pass we are maintaining the element that we have to sort. So we are taking one element, the first element from the unsorted list, and we are storing it in a variable temp. This is the element that needs to be positioned at its correct index in the sorted part of the list. Okay, so now temp is the variable where which contains the element to be correctly positioned, and j is maintaining the index positions in the sorted part. Since we compare temp with elements present in the sorted part from the right to the left, that means from the back to the front of the list. So initially the value of j in every pass would be I minus 1. Okay, so if we have one sorted element, I will be 1 and the value of j would be 0, because we have to compare temp with the element present at index 0, because only one element is present in the sorted list. Now when I will be 2, j will be equal to 1. It will be initialized to 1, and every time we will be decrementing j, okay, because we have to go towards the beginning of the list, so we'll have to decrease the index values. And when there are two sorted elements, j would initially be 1, okay, the second element in the sorted part which is present at index 1. Then if further we need to compare, j will be decremented to 0, which is the first element of the sorted part, and so on. Okay, now so once we are within one pass, in each pass we need to make comparisons with the sorted elements, and for that we need another loop. Now this loop will run as long as we are getting the elements which are greater than the current element present in temp, because as long as we are encountering higher elements, we will shift them one position behind their current position, and this will continue till we reach the starting of the list, starting of the sorted list. That means j becomes equal to 0. Okay, so we'll stop when j becomes 0, or when that means we'll stop when we have also checked and compared with the first element in the sorted part. And another way of stopping can be when we have found the correct position of temp in the sorted list. That means we have found an element which is less than. So this condition should either become false, or this condition should either become false. Okay, so but as long as both these conditions, why I'm saying both, because we have put an and, we have to run the inner loop, we have to keep on making the comparisons as long as we have not reached the beginning of the sorted list, and we have also not found the correct position of temp. That means we are still the elements that we are getting in the sorted part are greater than temp, so we need to continue when both these conditions are true. As long as one becomes false, we'll come out of the iteration, we'll come out of that pass, and we'll come out of this while loop. Okay, so if the condition still holds, then after the comparison, what you are doing, you have to shift the element which was present at location j to the index value j plus 1. So you compared the value of temp with the element present at index j. Now since this element is greater than temp, so you need to shift it one position back. That means you need to increase its index value by 1. So now you are positioning this particular element present at location j at index value j plus 1. Okay, and what you are doing, since now you want to compare temp with the element before j, so you decrement j. Okay, so when in the next loop iteration, the comparison will be done with the element present before the current j. Okay, so that is how we'll move from right to left in the sorted part. Okay, now once this loop is over, that means either we have seen all the sorted elements, and we have found the correct position of the temp would be the very beginning, or we have found any middle position where temp should be placed. So we now actually need to place temp. So temp will be placed at its correct location by this statement. Okay, and why we are doing j plus 1? Because when we come out of the loop, the value of j would be the value where would be the index value of that particular element which was found to be smaller than temp. That is why we want to place temp just after this particular element, and so temp would be placed at index value j plus 1, and we will increment the number of sorted elements, so I plus 1. Now this was the algorithm for insertion sort. Let us now quickly see the Python implementation of insertion sort, and then the same example that we considered in the theory lecture also. So insertion sort, basically this is the function that I have written for insertion sort. It is taking one argument, which is the list that we need to sort. Then it is calculating the length of the list using the length built-in function. Now inside this we are using a for loop, and this loop is maintaining the number of, it is keeping a track of the number of elements that have been already sorted. So I will be initially 1, it should be, so let's initialize I from 1, it should be 1 comma n. So now I will go to from 1 to n minus 1. If I had not written 1 here, automatically the first value of I would have been 0, but we assume I to be 1, so I have written range 1 comma n here. Now we are taking the element that we need to sort. So the first element that we will be sorting would be present at index 1, and the sorted element is present at index 0. So this is stored in temp, and the value of j is 0 for the first iteration when I is 1. Now this after this we will enter the second loop, which is the while loop, and we'll compare whether we have reached the end of the sorted part, that means the very beginning of the sorted part. If not, then we check the second condition, whether temp is less than the current element that we are comparing. If it is less than, then we shift this particular element present at location j to one step back. That means we will shift it to location j plus 1, and then we will decrement j. Okay, now when we decrement j, after this what we'll do, we'll again go back into the loop and check whether there are further iterations that we need to perform. That means, is temp still less than the new j that we have updated? If so, then we'll again shift the element present at index j to the index j plus 1, and this loop will continue. And when we come out of this loop, that means at the end of this particular pass, we will place the temp variable at its correct location, which is j+1. So let's execute this and this as well. So here also I've taken the same list, and as you can see, we have got the sorted list. Okay, so this was all for insertion sort. If you have understood this concept and you like this video and this helped you somehow, please let us know in the comment section, like our video and share it with your friends. Also let us know which other topics you would like to study from computer science. Thank you for watching. Till we meet in the next video. Mind your exam.